boys, here's the situation. Viviana has accused multiple people of being parasites in the group chat, and because I am the smartest man in the galaxy, and because I am obviously not a parasite, I have decided to contribute to the general well-being of my peers and help you guys do these math problems. That so number one, if b squared minus 4ac is less than 0, that means that the discriminant right here is less than 0, is a negative number, meaning that doesn't exist. There are no real solutions. Remember, it's imaginary. If it is equal to 0, then you're plus or minusing nothing. So there's only one real solution. And if it's greater than 0, then it's either plus or minus a certain number, meaning that there are two real solutions. Nice and simple, boys. Let's move on to the second question, which is a bunch of true or false. So, the terms under the radical sign in the quadratic formula is called the discriminant fact. The process where you change the equation to get into the form x plus a squared equals k, where a and k are constants, is called completing the square. That's true. This is the only question that I got wrong, because I thought completing the square was adding c to a equation, because I might not be the smartest man in the galaxy, but don't tell anybody that. Just remember that when you have like the entire equation squared, that's when you're completing the square. If you're giving an equation that is a perfect square, you must use the quadratic formula. That's actually true. I don't know why he marked it false. I think Mr. Bratcher might be like handicapped or something. This is obviously true. You need to use the quadratic equation for every single problem. Complex numbers can have both real components and imaginary components. That's true. Remember, he said it has to be a real part and an imaginary part, or else it's just imaginary. And I squared, which is -1 radicalized, is equal to -1, which is true, because that's how numbers work. So number 3 is a box of fun things, and it's pretty simple once you understand how to do it. So because you're radicalizing exponents, you can pretty much just have them. Like in the end result, it goes from 6 to 3 and 4 to 2, and then you could just simplify the numbers. So 50 would simplify to 5 2 squared, and then add the y with the exponent halved, so 5y cubed is equal to the square root of 2, and 100 is just 10, and then x to the 4th power is now x squared. Really nice and simple, not too difficult. Part B, very cool. This one's really simple. All you gotta do is simplify the number. So you can use the little slip he gave you, where it's all of the perfect squares, and just find which one fits into the number. That's what I did. And in this instance, it would be 36, and there's two 36s, and it's negative. So don't forget, you gotta get that I. So 36 squared, square root of 36, you got 6. And 2 can't be simplified any further without a calculator, so you just put 2. 6i square root of 2. Nice and simple. Part C. Oh, this guy was quite easy. Pretty much you just got to do what he does and just extrapolate it out. If you need to like write all this, if you're a little bit mentally handicapped and you need to write all of it out instead of just being able to visualize it, that's fine. And you can really simplify some things. You just take them out, extrapolate like that. 20 times the square root of 4, which you can just turn into 2. Bring that out, multiply it, because this is being square rooted. It turns into 2 because the square root of 4 is 2. And then because you're getting rid of the radical sign, it can now be multiplied by 20. So that becomes 40. Same with x squared. It gets square rooted, so it's just x. Boom, multiplied by 40, making it 40x, and 5 is just going to stay there. Same thing with this thing. As soon as you get rid of this, you can multiply them. But make sure it wouldn't be 9. That's where you're going to get in trouble. It would be 3 because it got square rooted. Great job, everybody. You did it. It's hype. It's hot. It's wet. We're going in. The most simple solution, even though this looks more complex than this one, technically it's more simple because there are no radicals in the denominator, which makes Mr. Bratcher very happy. So, in order to remove the radicals in the denominator, you're going to multiply, as he says, by a power of 1, which doesn't make sense because this is 4, not 1, Mr. Bratcher. But it's okay. And the reason it's negative is that we're trying to not like... Shut up. It's negative for a reason. Just do the opposite sign. I don't know why, but just do it. And you just do the math. It's quite easy. You know, square root of x3. Boop. And when I first saw this, I was like, what's happening? Shouldn't it just be 3x squared, or square root of x minus 4? But then I realized pretty much what you got to do is you got to visualize. There is a there's like a 3 in this case for the top part. There is a 3 for each part of what you're multiplying. So there's a 3 for the square root of x, and there's a 3 for the negative 4. So, and then you get this answer right here, and same right here. However, there would be a square root of x for this, and a 4 for this and this. But since they're the exact same thing, you can just simplify, because we did this in the polynomial unit, to just x minus 16. Nice and simple. See, it's moments like these when I'm copying the question onto Paint that makes me think, why wasn't I the #1 freshman instead of little Dominic with his small energy, when I am far superior to him in every single way, shape, and form? Really makes you think, doesn't it? Nice and simple. All you gotta do is FOIL, multiply these guys together, and you will get this big old boy. And then you combine like terms, and because you have I squared, because of 5i times negative 2i, that just becomes a negative, canceling out this, making it a positive, making the negative a positive. And bada bing, bada boom. Nice and simple. You got 16 plus 4, 1. Alright, this one's really easy because all you got to do is just combine stuff. So 7, pop, and minus, so just I, pop, 7i. I really, 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 really hope that nobody got this one wrong. Maybe Joseph did. Joseph probably did. But other than that, hopefully we're all good. Because it was really simple. All you gotta do is just combine the like terms. This is as easy as it gets. Oh, Papa Moist is now online. Hell yeah, boys. Papa Moist is my boy Mason. He's a legend. He would have had it so that I was the #1 freshman. Alright, question 4, part A. You just have to solve for x. And you can complete the square, or since these are both perfect squares, you could just bada bop, bada bingo, toastingo, you know what I mean? And simplify it nice and easy to +4 and -4. Oh, Badu Nips is online too? This is awesome. I can't believe it. Badu Nips and Papa Moist. Anyways, yeah, so you could just complete the square, but since you're lucky this is a perfect square already, you don't really got to do that. Question 4. This one is also quite simple. You just get rid of this guy right here, and thus get rid of that guy, making him 9, because you find the square root. Okay, then 2x minus 1 is equal to 9. And you just put the 1 over there, making it 10. So, wait, no. I take that back. Delete that part. Okay, pretty much you just pop it on over here, and 2x is equal to 1 plus or minus 9, meaning it's either equal to -8 or 10. Divide that by 2, and that's how you get your answers, boys. That simple. Alright, part C, question 4. Use any method to solve for x in the following expression. X squared plus 14x is equal to 15. Your boy is a genius after all, so he just pops this on out of here, like it shows. You get rid of this 15, and making it a full quadratic equation. And Mr. Bratcher says you could just factor it, but nobody is gonna remember to factor it. Okay, absolutely zero people are, and if you say that you did, you're lying. Okay, so you could just quadratic equation this boy, and you will uncover the exact same answer. The important bit is you're going to want to take this guy and subtract him from both sides. You want to have it equal 0. That's the number one. That's the number one stipulation. Okay. Question 5. This is another one of those questions that only Joseph got wrong. It's really simple. Just in case you guys need a refresher, this follows the quadratic equation exactly. It's ax squared plus bx plus c equals 0, which, this follows exactly. So remember, if it's x squared, a is 1, it's 7x, so it's 7, and the c is 16. So all you gotta do is just plug in the numbers there and use a little bit of cognitive power, and you will find the truth. Question 5. Using the values you put into the quadratic formula, how many real number answers are there for x? So you don't need to do the entire quadratic formula, you just need to do the part where it's b squared minus 4ac, right? And if this is a negative number, you know it's 0. If it was 0, then you know it would be 1. And if it was greater than 0, then you know it would be 2. Because guess what? We already covered this in the first question, right? So Mr. B hit us with that quick callback to see if you're really paying attention, because Mr. B is a genius, almost as smart as me, as we all know. This one's nice and easy. All you gotta do is realize, because they're asking for the v subset 0, which means the velocity, which is 22t, because that is the speed that it's going, times the time spent in the air. So this is how you find a location after amount of time. If gravity and starting height wasn't in play, it would just be like 22 plus the amount of time since it's been thrown. And the starting area, SO, would be plus 6, because that's just a static number. That's where he's throwing it from. So until it hits the ground, it's going to keep being plus 6 forever. B, I think a couple of people were struggling with this because Mr. What's-His-Face kind of explained it like a dork, and not in a way that a lot of people could understand. So, here's all you have to do. Is you need to calculate the c in the quadratic equation. So the part in the quadratic equation where... I should have written this out. Okay, so all you gotta do is find the discriminant right here in the quadratic equation, and find out what value c needs to be in order for all of this to equal exactly 0. That would be the max height, right? So you plug in your numbers. So b squared would be pretty big, 484. Okay, and then 4a, a is 1. No, a is negative 16. I don't know why I thought it was 1. But since it's minus 4a, that would mean it's plus 64c. So pretty much all you got to do, divide both of these guys by 64, and you will get 7.6. Right. Come with my special move, the retake. I was watching it back. I realized that I didn't explain this very well. Pretty much what you're going to want to do is, now that you have the b squared and the 4ac equal to 0, you're going to snatch this little doggy up and move them right over here. And of course, since you're subtracting, you got to go ahead and make this homie a negative. Then you are going to divide by 64, giving you 7.6 equals c. Discriminant is equal to exactly 0. That is the maximum height it will attain. However, we're not done. This is the maximum height it would attain if the fat referee had chucked it really high into the air from a position of 6 feet. If you remember, C was really 6 feet. We kind of played around and said, oh, C is 7.6. But in reality, it's 6 feet. So we're going to add the true C plus 6 to get our real big boy answer, 13.6. It is great. Everybody's happy. Well, you did it. You made it through, and you're ready for the exam tomorrow. We're all very, very proud of you. And remember, any achievements that you get are also mine. Also, I haven't been asked to sectionals yet, so if you ladies could just like form a line, we could sort this out nice and quick. Thank you.